And this is the answer key video to homework number 8. So we've got some fun typos. How does the Regents define an unusual event? So an unusual event, according to the Regents, an unusual event is an event that occurs outside of the central or middle 95% of the data. So for example, if you have a bell curve and you've got your 95% interval set up, that would be between -2 sigma and 2 sigma from the average. Any event that occurs outside of this central 95%, like this event or this event, those would be rare or unusual events. In a normal distribution, 68% of the scores fall between 72 and 86. What are the mean and standard deviation? So mine is a little slanted here, but I think it's symmetrical enough to follow. So you got x bar, which is the mean, which is not given to us, and we don't know sigma as well. But we do know that 68% of the scores fall in this range. So these must correspond to the -1 sigma and 1 sigma difference from the mean. So this must be 72, this must be 86. And between these two values is 68% of the population or the data. And we know that these are -1 sigma and 1 sigma here because that corresponds with the 68% interval. So in order to figure out what sigma and the mean are, we see that the total distance between these is 72, so 86 minus 72 is 14. So the total distance is 14, which means each half of this is 7 units from the average. Because these are 1 sigma from the mean, this is 1 sigma. And we can use these 7s to determine the mean as well. So if we have 72 here, and then we add 7 to it, that should put us at the mean, which would be 79. And a quick check shows 79 is also 7 units from 86. So the mean is 79 as well. A test was given to 120 students, and the scores approximated a normal distribution. If the mean score was 72 with a standard deviation of 7, then how many, let me label these x bar, 1 sigma, 86 would be 2 sigma, 3 sigma would be 93. Here we've got down 1 sigma, so that would be 65. Here we've got down 2 sigma, so that would be 58. And here we've got down 3 sigma, and that would be 51. So it looks like it's going to be a normal curve, symmetrically centered on 72. And I'm trying my best to make it symmetrical, but it's a little tough to do. So let's see. What percent of the scores are 65 or higher? So here we mark 65. The or higher part would be this part, and this one is a little bit cool to do actually, because you can think about it in 2 chunks. So this chunk between -1 sigma and 1 sigma, that's usually going to be 68% of the mean. So we could use that to determine not what this whole pink chunk would be, but let me undo those. But what this half of that, what this half of this would be. So because this is half of the 1 sigma group, this will be 68 divided by 2, which is 34. Now the reason I chose to break it up this way is if you look at the other part is exactly half of the curve, which would be 50%. So combining our 34% and our 50% gives us 84%. Okay, over the set of integers, that's a confusing sounding phrase. Let's talk about that in a second. Factor this expression. Well, I do know how to factor, and this does look like a sum and product, but with different exponents instead. And so if you remember from last night's homework or from the Unit 3, when you factor these, you factor it just like sum and product, but instead of having x and x, to make x to the fourth, we need x squared times x squared. And these will also give us the correct middle term of x squared when we distribute. Now we need something that adds to -4 and multiplies to -12. That would be -6 and +2. So this is actually the final answer. It's been completely factored. But I want to talk about this expression of completely factor this over the set of integers. Now, the reason I think they're specifying this is integers means whole numbers. So let's see how that comes up. Well, I should say, to be more exact, positive or negative whole numbers. So the reason why they're saying this is if you had x squared minus 9, we don't have that. This could be factored into x plus 3 times x minus 3 using difference of squares. Now, the reason why they specify that they'd like us to factor this expression over the integers is a really determined student might see this, and they might say, well, I could factor this into a difference of squares, but it's a little bit weird because 6 isn't a square. So maybe what they would do is, well, 3 times 3 gave us 9 over here. What times itself gives us 6? And they might think, oh, well, square root of 6 times itself does give you 6, right? Because when you multiply something by itself, that means that thing squared, which means that. So I think the reason that they specify this extra condition is to let students know that they do not have to do this. They only must factor it over the integers, so your factors should involve integers, not fractions, decimals, or, well, I guess square roots would be covered by decimals, so no irrational numbers either. All right, next up we take a look, so also just to be key, this is the final answer. If f of x is this, for what values of f of x does f of x equal 0? So we set this equal to 0. Now, this is tricky. It's not sum and product. It's not difference of squares. It's not GCF. Nothing divides all of these. It's not grouping. So I think that the two classes had different names for this technique, but this is the factoring method where a is not 1. And I believe the other class called it whack. When a, well, I forgot what the abbreviation stood for, but it was a good one. I can't remember what it was, but I'm sure someone will remind me. But because a is not 1 here, we can factor this by turning it into a grouping problem. So this is the key observation to make. Now to turn it into a grouping problem, we need to have 4 terms. We learned that the first term and the last term will remain the same. However, for your 2 middle terms, these need to recombine to give you 7x. And then the other condition that these 2 middle terms must follow is that they must multiply to make the same thing as these two. So if you do 6x squared times 2, that gives you 12x squared. So now you think, well, which terms would go here? And 3x and 4x look like they will do it. So it must be that we're breaking 7x into 3x and 4x. Now you could put them in either order. This order turns out to be the easier order. Perhaps if you do it the other way, you'll see why. But it does still work. So now that we have 4 terms, we can split it into 2 groups. This gives us 3x times x. Oh, that's not right. 3x times 2x plus 1. This one gives us 2 times 2x plus 1. Now we factor out the common factor, and we condense the 2 remaining parts to make the second factor. Now because these 2 multiply to make 0, it must be that either this one is 0 or this one is 0. And solving these really gives you x equals -1/2, or similarly x equals, I'm going to skip the math here, -2/3. So that looks like answer choice 3. Now 6 was really fun because it had complex numbers, which we haven't talked about in a while. But we've got this expression here, and we need to simplify it. So to square something, it means to take that thing and multiply it by itself. Now we've also got this thing times 2x plus 3i. And this turns out just to be a massive distribution problem. So 2x times 2x is 4x squared. 2x times negative I is negative 2xi. Negative I times 2x is negative 2xi. And I like to keep the variables the same. Oftentimes I'll do alphabetical. For some reason with I, maybe because it stands for the imaginary number, I like to put it at the end. But as long as you're consistent, you'll be able to find your like terms. Now negative I times negative I is positive I squared. Now we have a minus sign here, so we're going to need to subtract whatever we get from distributing. So using colors here, this minus sign is this minus sign. Now distributing out with the green marker, this gives us 4x squared plus 6xi minus 2xi minus 3i squared. So now we need to combine some like terms. So we get 4x squared minus 4xi plus I squared minus, and we'll distribute all of these, so minus 4x squared. I'm going to combine these first before distributing. That would be 4xi, but now we distribute the minus sign to it. That gives us negative 4xi. And then lastly, wow, I distributed so much there. Negative times this gives us positive 3i squared. Now, let's see. We got 4x squared and negative 4x squared. Those cancel out. We've got negative 8xi when we combine these two. And then we have plus 4i squared. So, it's a little bit weird. We didn't get one of our answer choices. But hopefully you have a distant memory, because I is the square root of negative 1. It can't be simplified as just I, but if you square both sides, you find that I squared is equal to negative 1. And that means we can do a replacement here where we make I squared negative 1. This will give us an answer trace that matches up. We get negative 8xi minus, or well, I'll just do it in two steps, plus 4 times negative 1, negative 8xi minus 4. And that is answer choice 1. For problem number 7, we need to find the inverse of this function. So we've got inverse means that we want to switch the input and output. So we rewrite this as y equals 1/2 x plus 8. Switching x and y gives us the inverse function. Now all we have to do is solve for y. So the steps to do that are minus 8. That gives us x minus 8 equals 1/2 y. Multiply by 2 on both sides. Remember, when you multiply by 2, you're distributing that to this whole side. That gives you 2x minus 16 equals y. And they're calling the inverse g of x this time. So we get our answer choice. Now for problem number 8, this one is a throwback to, I'm going to misremember this, but I think it's unit 6. This one was unit 5. This one was unit 1. This one was unit 3. This was unit 3. Oh, we already put that one. Okay, cool. So this is unit 6, which we did a bunch of stuff with these fractional equations. And we do know that to add two fractions, we need a common denominator. But one extra thing we saw that was beneficial is with these problems, it's often helpful to get everything to have the common denominator. So thinking about the pieces that we have here, x plus 3, 2, 6, and 2. Well, we can turn the 2's into 6's pretty easily. So that would be like a times 3 here and here, and here and here. And then we'd have 6's for all of those, but this one needs a 6 also. So this one I'd have to do 6 times this, 6 times this. And then all of the other fractions are missing this x plus 3. So we'd have to include that x plus 3 in all of these places as well. So it does take a lot to get a common denominator here. But I think if we go through all of these steps, you'll see that all of the denominators match up. Let's prove it. 1 times 3 is just 3. And then 3 times x is 3x plus 9. All over 2 times 3 is 6. 6 times x is 6x. 2 times 3 was 6. 6 times 3 is 18. Now over here we do x times x, which is x squared. X times 3, which is 3x. 6 times x is 6x. 6 times 3 is 18. And then over here we've got minus, and then we do 1 times 3 is 3. 3 times x is 3x. 3x times 3 is 9. Now here you have to be careful, and I've intentionally been a little sloppy in how I wrote this. This minus sign is applying to this whole fraction, so we actually are going to be subtracting this whole group. That's the minus sign from the problem. Now down here we get 2 times 3 is 6, times x is 6x, plus 18, or plus, sorry, 6 times 3 is 18. And you see that all the denominators match up. So we know that our steps, well, perhaps you remember that our steps are going to be to add these two fractions together, add these two fractions together, which is not going to change the denominators. Then we'll end up with, I believe we used a smiley face for it since we didn't really care what the denominator was. Let's see that. So 3x minus 9 when we combine these two, all over some denominator, which is going to be 6x plus 18, but I like to write smiley face. And then over here we get x squared, positive 3x minus 3x is 0x, they cancel out, and then minus 9. And that's all over the same denominator, 6x plus 18. But because, well, let me actually just write it this time. I hope the smiley face reminded you of the unit, but just for the sake of clarity, because we haven't seen one of these in a while, I'll leave it as 6x plus 18. Now the next step would be to cancel out the denominators. So we can multiply by 6x plus 18 on both sides. This will cancel out here. And because we're doing the same thing here, and we have the same denominator division, and multiplication on this side cancels out too. That gives us 3x minus 9 equals x squared minus 9. Now, we probably want to factor this, so we'll get it equal to 0, minus 3x plus 9, minus 3x plus 9. That gives us x squared minus 3x. Negative 9 and 9 cancel out. And on this side, we had nothing left, so it's all equal to 0. This can be solved with GCF factoring. So we get x times x minus 3 equals 0. And setting each of these equal to 0, we find that x is 0 and x is 3. Now there were a couple of things that we need to do to finish this up. So perhaps this is distant in your memory, so you didn't think of these steps. But one step you could have realized was, with all of these same denominators here, because we know we're eventually going to multiply by that denominator and cancel it out, we can actually cross out all these common denominators here, and perhaps that saves you a step or two. Now another thing you might not have realized was, because this is a fraction problem, prior to doing any of this work, we should have done something called a pre-check. So a pre-check is a way of guaranteeing that our answers won't be extraneous. Now, the one thing you have to check for with fractions is make sure you don't divide by 0. And so 2 is never going to cause you a problem, 6 is never going to cause you a problem, 2 is never going to cause you a problem, because these numbers will never be 0. However, x plus 3 is dangerous, because depending on what x is, this could equal 0. So since x plus 3 is here, we know that x cannot be negative 3. Because if x were negative 3, that would have given you 0 in the end for this denominator, and you cannot divide by 0. So our pre-check says x can be anything except negative 3. And since negative 3 is neither one of our answers, both of our answers check out, and we have our solution set. All right, guys, I hope this was helpful and reminded you of some of the things you've learned this year. I'll see you in class tomorrow.